So let's see today's GFG problem of the day. So what question says that you will be given an array and an integer k. K is basically number of students. You have to allocate these books to the student, and each book contains some pages that is written in this integer form. And you have to the objective is to minimize the maximum number of pages assigned to any student. Like we have to distribute in such a way that the minimum number of pages any student get should be maximized. Basically means we have to minimize the number of pages any student can get of like from all the student. The minimum number of pages any student has, that should be as minimum as possible. Like to try that every student get as number of book, and last the minimum number of pages any student has should have as minimum as possible. So I have taken the test case from the question, and the k is equal to what? K is the number of what student. Here it is 2. So what could be the minimum number of pages any student can get, minimum value in the array, and what the maximum number of pages any student can get, sum of all these. So we are for sure that the answer will lie between the minimum and the sum of these, that will be 203. So sum will be definitely between them. So what you can do, you have to do some kind of binary search. Why? We know that the answer will lie between this and this. So you will take left as this and right as this, and you will try to check if mid is possible or not. How you will check? You will try to assign greedily everyone so as to not increase this value, because mid is, if our mid is answer, then no one should get greater than mid. If they are getting greater than mid, then the answer will not be our mid. So we have to just check how many student can mid, if the mid is the number of minimum pages any student can get. So how many part in which we can divide? Like left is 12, right is 203, then the half of this is around 107. So I will try to give 107 pages, so it will break here, so it will give in 2 students. So similarly you have to move left and right, and you will ultimately reach to answer. Why we are doing this? Because anyhow the sum of the pages is going to be a constant, and how we can minimize the number of pages and any student can get, we have to give the maximum number of pages we can give. Not maximum, now we have to give the number of pages equally divided into equally. If suppose it was not an array, we have only pages, then we will just divide the number of pages by the number of student, and that is k. But in this k, pages are in the different book, so we'll try to give the book number of pages as close to every student as possible. Like it is not like some student can get a very less page and some student are getting very high. So like this, we cannot give someone less, someone greater. So we are trying to give as close as possible. If they are, we are giving as close as possible, so the minimum of them will automatically will be minimum possible, because sum is going to be a constant. If you are giving someone minimum, you will automatically get someone who are getting greater, so our answer will also increase. That we don't want. So that's why we are using binary search, so as to find an optimal value that make all in such a way that we can get an answer.